Welcome to East Academia. My name is Brian, and today we are going to talk about removable continuity. First of all, what is this concept that is known as removable continuity? So, removable continuity. Before even I introduce you to removable continuity of a function, I'm going to give you the three necessary conditions for a given function f of x to be defined. Okay, so f of x is defined if it has to satisfy the following three conditions. The first one, f of x is defined at a particular point a. So f of x is defined at a particular point a. Okay, so some texts easily write this that f of a is defined. Okay, so this means that when the value of x is a, this function is defined. All right, so this is the first condition, f of x is defined. The second condition for a function to be defined is that the limit as x approaches a of f of x is in existence or exists, something of that kind. So this limit as x approaches a of f of x exists. Now, the third condition is that f of a is equal to the limit as x approaches a of f of x. Are you together? Yeah, so these are the conditions for a function to be defined. All right. However, for a function to be continuous, because you're talking of continuity. However, we have instances whereby a function has what is known as removable continuity. Okay, so then what is removable continuity? It means that this function is defined, okay, or maybe it does not satisfy some of these conditions. Okay, so maybe f of a is not defined. Okay, but at this limit, of course, on direct substitution, if this is not defined, on direct substitution, this limit will not exist. But you can employ other techniques of evaluating limits like the L'Hopital's rule or factorization, and you get a limit. Okay, so and of course this one, number 3, will also not hold. Okay, so removable continuity, this means that the limit of the function exists, but maybe f of a is not defined, and this number 3 is not held. Okay, all right, so that is what we call removable continuity. Now we shall go to questions. Okay, so I'm going to begin with an example, and then I'm going to give you an exercise as usual. So I'll write here example. So what is the example today? Example today says that investigate the continuity of f of x given that f of x is equal to x raised to power 4 minus 81 over x squared minus 9, and this is at x is equals to 3. So solution. So solution. Now, in this case, how we go about solving this one is that we are going to take the 3 requirements for limit for a function to be continuous. Now, is f of a defined? That is the first thing that we are going to ask ourselves. Is it defined? So we just replace f of a is going to be 3 raised to power 4 minus 81 over 3 squared minus 9. Of course, this will be 81 minus 81 over 9 minus 9, which this is going to be 0 over 0 is undefined. All right, because it's infinite. Okay, the second question, the second condition is that the limit as x approaches a. Now in this case, limit as x approaches 3, over x raised to power 4 minus 81 over x squared minus 9. Does it exist? All right. So now, as usual in evaluating limits, you begin on direct substitution. You get, of course, you're going to get this, whatever you just evaluated here. Direct substitution, you get 0 over 0 and defined. Okay. However, you can use different technique. Now, when you look at this is a difference of two squares. Okay. So then notice the difference over two squares. You can rewrite this in terms of a difference of two squares such that it becomes limit as x approaches 3 of x squared minus 9, all right, x squared plus 9 over x squared minus 9, all right, and this will cancel, okay, and upon substituting this one here, now you get it's 9 plus 9, which is 18. So the limit exists. So condition 3, does f of a correspond to the limit? Okay, so it doesn't, all right. So f of x has, then now our conclusion will be that the function f of x is equals to x raised to power 4 minus 81 over x minus 9. We say it has removable continuity. Removable continuity at x is equal to 3. Right, so I hope I'm clear. Yeah, so the function has a removable continuity at x is equal to 3. Calculus is not difficult, as you can see. These are things that we just manage. All right, so for the exercise today, So for the exercise, investigate the continuity of the function f of x, given that f of x is equals to x squared plus x minus 2 over x minus 1 at x is equal to 1. At x is equal to 1. So pause the video, try solving it, and then we are going to solve it together. Okay, thank you for attempting. And so now we are going to the solution, straightforward. So what is f of a? F of a, we are going to get it's 1 plus 1 minus 2 over 1 minus 1. We'll get 0 over 0 and defined. All right. And what about the limit? The limit as x approaches 1, x squared plus x minus 2 over x minus 1. You're going to get on direct substitution, you're going to get a 0 over 0. Okay. But in terms of factorization, what do we get? In terms of factorization, we think of a number that we can factorize the numerator. So x squared plus x minus 2 is equal to 0. So we are thinking of a number that the sum, okay, sum is 1, and the product is minus 2. Of course, the other methods that you can see, like for me, when I look at this, I know this one, it's a matter of a plus b or something. Just look at it and know, right? But you can go this other way, or you can even use a calculator to get these solutions. So which number has a sum given by this coefficient of x, 1, and a product given by this product of this coefficient, which is minus 2? All right. So what two numbers are those? Now, if you look clearly, the two numbers are 2 and minus 1. All right. So then this means I can change this this minus x here to be plus 2, okay, plus 2x minus x minus 2 is equal to 0. Still the same thing. So then what happens here? Here we can take out x and you get it's x plus 2. And then here we have this minus here and take its x plus 2 is equal to 0. So we're going to get its x. We have 1 here, of course. So it's x minus 1, x plus 2. isn't it? So we can now rewrite our limit. So it becomes now limit as x approaches 1, x minus 1, x minus 2 over x minus 1. So this and this will cancel. Yeah, this and that and that is going to cancel. This is x plus 2. So then when you substitute with 1 here, you're going to get that this limit is giving us what? Is giving us 3. So now the third condition of continuity, f of a is not equal to limit as x approaches a of f of x, isn't it? However, this limit exists, so we conclude that f of x has a removable continuity. So we'll say f of x has a removable continuity at x is equals to 1. So something of that kind. So thank you for watching Mr. Academia. Remember to subscribe so that you get more. Thank you.